Hi Geometry, this is page 501 of our books, and this is unit for lesson 10 notes. So first off, we look at these three polygons inscribed inside a circle. The first one being a square inscribed inside my circle. The second one being a hexagon with 6 sides. And the third one being a decagon. My decagon has 10 sides. So the first thing I want to talk about is the square. I'm going to do it differently than the other two polygons. So let's get started. On these problems, you and I are going to find the perimeter, that's the distance around, and the area of each polygon. So we're going to use the information given to help us figure out the rest of it. So let's get started on the square. So first of all, we've been working with squares. I know if I draw in these diagonals, I split my square 90-degree angles into 45, 45, and I know my diagonals intersect at a 90-degree angle. So I have right here a 45, 45, 90 triangle. And I know that my two legs are my perpendicular legs, so they must both have a distance of 1, which is also the radius of this circle. So my two legs have a distance of 1, and this side right here is my hypotenuse of this 45, 45, 90 triangle at the top. So I know by my 45, 45, 90 formulas that the hypotenuse equals rad 2 times a leg. And if my leg is 1, then I know that my hypotenuse is rad 2 times 1, or rad 2, which is approximately 1.41 something, 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 but I'm going to leave it rad 2 for the moment. So I know that this is rad 2, this is rad 2, this side's rad 2, and this side's rad 2. So I can calculate my perimeter of this. I have 4 sides, and all 4 sides are rad 2 in length. So my perimeter would be 4 rad 2, or rad 2 plus rad 2 plus rad 2 plus rad 2 would also equal 4 rad 2 units. My area, the area of a square is base times height, or sometimes we write side times side, or side squared. And so this would be the side squared. And when I square a square root, it just cancels, and I would get 2 units squared. I don't want to write into my hexagon area over here. So those would be my 2 answers for my square. So my hexagon and decagon, I'm going to do slightly differently. So these polygons, I'm going to use the idea that they can be divided into triangles again. So let's divide my polygon, my hexagon here, into 6 triangles. And I'm going to find the area of one of these triangles, one of these red triangles, and then I'm going to multiply by 6 because there's 6 of them, and that will give me the total area of my hexagon. So I need to do a little work to be able to calculate the area of this triangle. So first of all, I'd like to know the angle that's right here. So I can split it in half with my altitude. I'm going to drop an altitude, which is perpendicular to the base. And then if I could find that altitude, that would be my height. This would be my, and if I could find my base, this would be my base. And I could calculate the area of that red triangle. So let me move my paper a little bit so I have some room to write down here to the side. So when I work inside my triangle, step 1 is that I'm going to count my total number of triangles. So in this problem, there are 6. So then I know that around this center point up here, this center point right here, there's 360 degrees. So if I do 360 degrees divided by those 6 triangles, I know that each triangle is 60 degrees. So like this angle right here, the whole thing is 60. So when I drop that altitude, and let me do it in blue. So this is the altitude, this perpendicular altitude I'm dropping. When I drop that altitude, I'm splitting that 60-degree angle in half. So when I divide it in half, I get a 30-degree angle. So inside this little triangle, this angle right here is 30 degrees. I just made a 30, 60, 90 triangle. However, I'm going to use trig. But just so you know, you could do your 30, 60, 90 rules for this problem as well. So I've done my angle. I have step 2. I've already drawn my blue altitude, splitting that triangle in half. I can see that. And then my third step is, let me go back to my red, is I'm going to use trig to find, and it depends, each problem's different, but in this problem, I don't know my base, nor do I know my height, the height being the altitude. So let me write that in parentheses. My height is actually that altitude. I need to go find it. So I need to find both of them in this problem. So coming back up here, I'm going to work inside, and let me draw it here so you can see it better. This is my 30, 60, 90 triangle with a side of 1, and my altitude in the picture I drew in blue. So that's me just bringing this triangle out so you can see it a little bit better. So let's use our trig. This is the side opposite the 30. This is my hypotenuse. This blue side, my altitude, is adjacent. So if I want to find my altitude, which is the blue side, I'm going to use cosine of 30 equals my adjacent side. Let's call this y, because I think I do that in my workbook. We'll call the opposite side x. So I have y over 1. Now, the 1 is significant. It could be 2. It could be 3. So I'm going to write it, even though I think we're all thinking, oh, you're going to multiply both sides by 1. But yes, you are multiplying both sides by 1, because that may not be a 1 there in your next problem. So anyways, let's multiply both sides by 1. Let's find the cosine of 30, and you're going to find that that is 0.866. So this side is 0.866. This side up here is 0.866, this blue side. And then I'm going to do sine of 30 equals x over 1, multiply my 1 over, do the sine of 30, and I'm going to find that my x side is 0.5. So this is 0.5. This is this little side right here. So I know the entire side is 1. And that makes sense. You know why that makes sense is because these are 6 equilateral triangles, only because they're in a hexagon, by the way. So it makes sense that it's 1. But anyways, if it wasn't a hexagon, I would have to do all this work because I wouldn't know what it is. So I got those two values. I can calculate the area of a triangle. The area of a triangle is 1/2 base times height. And so I'm going to use that to calculate the area of my whole polygon. So the area of my hexagon, my polygon in this picture, is equal to my area of the triangle, 1/2 base times height, times the number of triangles. So in this problem, it's 1/2. My entire base is 1. My height of my triangle is 0.866. That's the area of one triangle in my picture, and I have 6 of them. So now I'm going to put 0.5 in my calculator, I'm going to put my 0.86 in my calculator, and I'm going to put my 6 in my calculator, and I'm going to get 2.598 units squared. That's my area, and I haven't done my perimeter yet. I'm going to take my side length of 1, and I've got 6 sides, so my perimeter is 6 units for this triangle. So now the decagon. I'm going to do this the same way. On the next page, I'm going to show you another formula that you can use for this, but it's actually the exact same work. But we're going to calculate the area of one of these triangles. So let's pencil in our triangles. I've got 10 of them, 10 kind of skinny triangles. So take a little bit of time and draw in your 10 triangles. And we are going to find the area of one of these. And so again, I'm going to take my 360 and I'm going to divide by 10, and I get 36 degrees. So one of these triangles, the whole angle is 36 degrees. But in the triangle I'm going to use to calculate my area, I need this perpendicular height. So I'm going to drop in my altitude of that triangle. And so now I need this little angle here, and that would be 36 divided by 2, or 18 degrees. So I know that this little angle is 18 degrees. I'm going to draw this triangle out here a little bit bigger, so I have some room to write on it with you. So this is my triangle, this is my 18 degrees, and this is my radius of my circle, which is 1. And so I need to find my side length, so we'll call this x again, and I need to find my altitude in order to calculate the area of this triangle. So let's get started. I'm going to use sine again to find x. So sine of my 18 degrees equals x over 1. Multiply your 1 over sine of 18 is approximately 0.309. I'm going to use cosine to find my y. So cosine of this 18 degrees is y over 1. Multiply your 1 over and calculate it. And cosine of 18 is 9.951. So I know this height in here is 0.951. Again, on my drawing, it's this blue height right here. And I know that half of my base of my triangle is 0.309. This little half right here is 0.309. So that little half will help me find the entire base, this entire base right here. I have to double 0.309. So that entire base of this triangle is 0.618. So now I'm ready to find the area of this, and I'm going to shade it in, so it's going to look a little messy here, sorry. But I'm going to find the entire area of one of my 10 triangles. And I'm going to use that to find the area of my polygon, my decagon, because I'm going to find the area of this one triangle and I'm going to multiply by 10. So in this triangle, my entire base of my triangle is 0.618. My height is the altitude, 0.951. And I'm going to multiply that by 10 because I've got 10 triangles in this picture. And so when I do that, I get 2.94 units squared. So now what about my perimeter? Well, I have 10 sides, and they are all 0.618 in length. So my perimeter would be 6.18 units. This is the next page, page 502. And I want to discuss with you another formula that you might see with finding the area of polygons. So a popular formula is the formula, so the area of a polygon equals 1/2 the perimeter times the apothem. So you'll see that in places, and I want to discuss it. So that is area equals 1/2 perimeter times the apothem. And let's go ahead for number 2, we're going to draw a regular pentagon. Go ahead and cross out everything after the regular pentagon and write width side 6 centimeters. So let's go ahead and draw that. So a pentagon has 5 sides. This is a regular pentagon, so it's important that all 5 sides appear to be the same length and all 5 interior angles appear to be the same. So your regular polygon should look something like this. So what do we mean by the apothem? This apothem right here. Well, this is the center of my pentagon, and the apothem is a segment that goes from the center perpendicular to a side. So really what the apothem is the height, the altitude of all these triangles we drew on the page before. All those blue altitudes, which ended up being the height of my triangle when I calculated the area, that's what an apothem is. So the perimeter, if you think of the formula we were just using, we're calculating the area of one triangle and multiplying by my number of triangles, the number of triangles. Well, the base length times the number of triangles, that's really your perimeter. And height is another word for your apothem. It's really the exact same formula. So for me, if you like the idea of finding the area of a triangle and multiplying it by how many in the picture, great. If you would like to try using this formula, I'm going to do the next two problems with this formula. If you like it, great. It's the exact same math. It's the exact same trig. You're finding the exact same values. It's the exact same thing. But I wanted to expose you to it just in case you came across it somewhere else. So let's take a look at number 2. Number 2 is a pentagon. You can see, if you sketch them in, you can see the 5 triangles in the picture. And that apothem I drew in, I'm going to make it blue. I'd like to make this stand out. This is from the center perpendicular to one of my sides. So to do this problem, I still need to figure out that blue apothem, and I don't need to figure out my side length this time. I do know the entire side is 6, so this little half right here would be 3. But I still need that blue length. So I'm still going to use my trig on a little half of a triangle. So I'm still going to take the total of 360 degrees around the circle. I'm going to divide by the 5 triangles I see, and I'm going to get 72 degrees. Now that's the entire angle all the way around the circle, and I'm using half of that. So I'm going to take my 72 degrees and I'm going to divide it in half, and I get 36 degrees. So this angle, I'll do it in blue so it stands out. This little angle right there, that's my 36 degree angle. Let me draw that triangle a little bigger so we can work with it. So I have my blue height, and then I have my other half of my triangle. This is my side, that's 3. This is my angle I just put on there, that's 36. And so to calculate the area, I just need to find this blue height. So this would be my adjacent side to 36, and the 3 would be my opposite side. So it looks like in this problem I want to use tangent of 36 equals, we'll call this guy y, equals my opposite over my adjacent. So let's multiply our y over. Let's divide by our tangent 36, and I get 3 divided by tangent 36. So my blue height there is, sorry, let me grab my calculations, 4.13. So this blue distance is 4.13. So now I'm ready to do my math. My perimeter is going to be my side length is 6 times my 5 sides, or 30 centimeters, since that was my units. And I didn't mention this, but we're going to calculate the area as well. I'm so sorry. And so then the area, you could find the area of one triangle and multiply by your 5, like we did on the previous page, or let's practice this formula. Area equals 1/2 the perimeter, which is 30, times the apothem, which was 4.13, and so my area is going to be equal to 61.95 centimeters squared. At this point in the classroom, I'm going to go to a worksheet with 9 problems that you use this skill to calculate the area of. And that is a second video for this lesson. And I'll see you on the next video. Bye.